In this section, we're going to use a student t-distribution to estimate a single population mean. So we're going to discuss a confidence interval for a population mean, but because we're taking samples from a sampling distribution, we have a special distribution called the student's t-distribution. Okay, so the point estimate for a population mean is x bar, as we know, with the population mean being mu. So in this example, we have pennies minted after 1982 that are made from 97.5% zinc and 2.5% copper. The following data represent the weights in grams of 17 randomly selected pennies minted after 1982. Treat this data as a simple random sample, and let's go ahead and estimate the population mean weight of pennies after 1982 and round to 3 decimal places. So here, what the first thing we want to do is take a point estimate right? So the point estimate would be x bar. So notice they gave us raw data. So we'll have to go ahead so let's go ahead and enter these weights of the pennies in the calculator. So we'll have to go to stat and go to edit and kind of edit, our list again. Because essentially, remember that in real statistics in your research method class, you'll always be given raw data. So let's go ahead and put them in 2.46. And so there should be 17, and sure enough, there's 17, and my calculator has 17 data. So now, in order to get the sample mean, just go to stat and then go to calc and one var stats. But mine is list 2, so I'm sure yours is appropriately list 1. Let me clear that out and then hit calculate. And so it says to round to 3 decimal places, so we'll round 2.464. So what the box above is saying is that the point estimate of mu is x bar, which is 2.464, and then pennies are weighed in grams. So that's not too bad. We just use the calculator to kind of do all those calculations. Okay, so because remember we're taking sampling distribution, so remember we have this population where we take a lot of samples, right? We learned about this in chapter 7, right? And these are a bunch of little samples here. So when we do and we evaluate that sample, and if the population from which that sample is drawn follows normal distribution, then the sample in which we're using to estimate a population parameter uses the student's t-distribution. And so, and the only difference here is we use degrees of freedom. And we have to think about back when we kind of thought about the standard deviation, and when it was a sample, we wanted to subtract that denominator by 1. Because recall, like if you had 5 pencils and 5 students, right? And that first student that comes and picks can choose from all 5, right? And they take 1. The second student that comes in only has 4 to choose, but they still have right? They still have freedom to choose, and so they take 1. That third student comes, has 3 pencils to pick from, and has the freedom to choose. And that fourth student that comes in has 2 to pick from, so they actually still have a pencil to choose, right? That freedom. But the fifth student does not have a choice, right? Doesn't have any freedom to pick which pencil. So it's stuck with this pencil whether they like it or not. And so that's where the n minus 1 of degrees of freedom comes. So if we're taking samples from a sampling distribution in which the population is normal, or approximately normal, we can use a student t distribution. And notice it's just this kind of looks like a z-score, except all we're doing is dividing by that square root of n in the denominator. Okay, so what does it look like? So this is the t distribution, and then here's where t is equal to 0. So notice they're similar to z-scores, right? And they follow the same normal curve. So again, because the population's normal. And then we can see that the only difference in the t distribution is that you have n minus 1 degrees of freedom, DOF, right? And the only difference is that denominator, or that standard error that we know, is going to have to, the denominator in that t-score will be divided by the square root of n. Okay, so what are the properties of the student's t distribution? Well, the t distribution is different for different degrees of freedom. So up here we could see that these red, green, and blue lines is when the degrees of freedom change. So notice it just changes a little bit. The t distribution is centered at 0 and symmetric about 0, similar to the z-scores, right? The area under the curve is still 1, and it's still half on each side, so it still holds to that 100%. As t increases or decreases without bound, the graph approaches a never equals 0 still, right? It has those horizontal asymptotes. And the area in the tails is a little greater than the area in the tails in the standard normal distribution. So this is one of the bigger differences. Everything seems to be the same except this, where the area in the tails are going to be a little bit more than the z-scores. And that's because we're dividing that square root of n in the denominator. And then as the sample size n increases, the density curve gets closer to the standard normal distribution. So that's like the z. So, you know, as the sample size increases, then t gets closer to the z's. Okay, so and it's similar to samples, right? As sample size increases, and s gets closer to sigma. So same with the standard deviation. So essentially, as the sample sizes get larger, the t becomes the z, and therefore the standard deviation, sample standard deviation, gets closer to the population. Okay, so then for the alpha, right, we use the same notation, right, where this alpha is still area to the right. And we'll go ahead and note that somewhere here, right, maybe here, right, so, and then alpha is this area, and then we have t sub alpha. So it's still it's still the same notation. Okay. So if we're given the area, in this case to the left, we can actually find the t value. So our calculator allows us to find area to the left of the value of t. So if we know the alpha, or area to the left, then we can use the calculator to find the t value. So normally there are tables out there like that we could use, but in this class and you may have taken, if this is your second time taking statistics or however many, if you've been in a statistics course prior, they may have used tables, but it's just is so archaic because I mean, using the calculator is somewhat archaic, right? Because we would just do this all in like SPSS or Minitab or some sort of, sophisticated statistical software. So we just aren't going to go ahead and get our feet wet and just use the calculator. So we're not going to use tables in this class. We'll just use the calculator. Or you can use an online calculator as well. So all you have to do is go to the second vars and then MT and then get the area from the left and degrees of freedom. So in this case, let's just practice. So we'll find a t value such that area under the t distribution to the right of the t value is 0.2. So here is t sub alpha, right? And the area in this tail here is 0.2. Okay, and then we're assuming, so we know alpha is 0.2, and then we're assuming that degrees of freedom is 10. And then, so t.2, let me just draw it really nicely. So t sub 0.2 is equal to, and that's what we can put in the calculator. And what we're going to do is put in t area to the left. So what is this area to the left? Well, if alpha is 0.2, that means 1 minus alpha is equal to the area to the left. So 1 minus 0.2 is equal to 0.8. So this area over here is 0.8. And that's the area that we input into the calculator. Okay, so all we have to do is put 0.8, comma, degrees of freedom, 10, and get our t value. So let's go to our calculator and clear this out. Hit second vars. Go down to MT number 4. Now I hope all of you have downloaded this calculator if you didn't have it before, because older calculators will not have this feature. So it's really important that you download that calculator for this feature. So 0.8, we had degrees of freedom of 10, and then we'll paste it in, enter. And so here we'll go ahead and round to 2 or 4 decimal places. So 0.8791. So this t distribution, t value with 10 degrees of freedom and an area 0.2 or alpha point is equal to 0.2 is 0.8791. So we're just going to go ahead and always use the calculator. In the homework, you'll also have to use this calculator feature, so make sure you mark it.